Okay, so good morning, everybody. I would like to firstly, I would like to welcome all of you to this program, Innovate Malaysia Co-Design Competition to 2021. Yes, this is online grand finale program and under Intel track judging session. Okay, and then I'm session chair for this program, Zaini binti Abdul Halim from University Science Malaysia, and I'm in lecturer at School of Electrical Electronic Engineering in USM. Okay, so in this program, we have yeah. So these are the judges that will evaluate your performance or your project. Yeah. Since I think this one is almost 1 year, it's been given to you for your project, and today is the the final competition. And this is the list of judges: Mr. Andrian Yeo, Mr. Hadri Chan Balasubramaniam, Mr. Izrul Akmal Abu Hassan, Miss Lim Mei Wee, Mr. Lu Tung Lun, Mr. Michael Uy, Miss Ng Kei Lee, Mr. Wong Swee Heng, Mr. Yip Kim Choi. Okay, so these are the list of judges that evaluate your presentation. This is for your presentation. You are given 15 minutes to present your work, and coordinator will remind you at 14 minutes and announce times up at 15 minutes. After presentation, you have 5 minutes for Q&A, and then judges will have about 1 to 2 minutes to give feedback to your project and presentation. Okay, so before we proceed, I would like to introduce the first group that will present. Yeah, the title of their project is System on Chip Design and Implementation of ECG Delineation Algorithm from UTM. Okay, this is the second group, Implementation of Car Plate Detection on SoC Platform from USM. And this is the third group, the development of smart on-road surveillance system from Swinburne. This is the fourth group, COVID-19 mandatory self-quarantine wearable device for authority monitoring with age AI reporting and flagging system from UMP. And this is the last group that will present today, entitled of 2D OCDMA encoder decoder for various industrial application from Unimap. Okay, so these are the list of projects that we'll present. So please make sure you, present according to the, list that I've mentioned just now. So without any delay, so I would like to invite the first group to present your work. Before that, I would like to unshare this my video.
Thank you. May I have the request to control for the share screen? Hello.
Is Dehan there?
Yes. Okay, it's already.
Okay. Assalamualaikum warahmatullahi and good day. Good
Morning, ladies and gentlemen. Let me introduce my group. We are from group MY067. Team members are Dehan Amalda Hadiana, Mutia Rahmah, and Noval Fikri Muhammad. We are supervised by Dr. Hao Yuan Wen, and we are from School of Biomedical Engineering and Health Science, Faculty of Engineering, University Technology Malaysia. Proudly presents our product, System-on-Chip Design and Implementation of ECG Delineation Algorithm. Next. Did you know the #1 cause of death in Malaysia, even in the world? Yes, that is cardiovascular disease. The data said in 2019, 17.9 million people in the world had this disease, and it represented 31% of all global deaths. Cardiovascular is a general term given for conditions affecting the heart and blood vessels, and also this disease is the #1 cause death in Malaysia, with 18,267 lives deaths in 2019. And then one of the common medical devices to detect this disease earlier is electrocardiogram or ECG. The function of this medical device is used to read heart electrical activity, and the result can show the heart's conditions and diagnose disease when there is an abnormal conditions. In ECG itself, will consist of P, Q, R, S, and T wave. Next. This is our project breakdown. As I said before, ECG consists into 3 components. The first one is P wave. P wave is depolarization of the left and right atrium and also corresponds to atrial contraction. There is also QRS complex. It is electrical impulse as it spreads through the ventricles and indicates ventricular depolarization. Last but not least, there is T wave. That is repolarization of the ventricles. Next.
Okay, now I'd like to tell about the challenges of existing ECG delineation algorithm. So the first challenge is there are many of the existing ECG analysis software that is running at the high-end workstation or desktop for post-analysis purpose due to complex algorithm, hence not suitable to be integrated with portable heart monitor. The second challenge mostly cannot provide full ECG annotation, especially onset and offset of P and T wave due to similar characteristics. And the last point, most of the algorithm is still modeled and simulated at high level rather than executable solutions. Next. Let's turn now to why FPGA. First thing, FPGA is ideal for real-time application due to the flexibility. They can carry out complicated calculation in a short period of time. FPGA has high computation capability that make FPGA useful for high load computation. It is also super parallel computation as well as can be reprogrammed, which is suitable for an early development. Next. Moving on to our solution, system-on-chip design and implementation of ECG delineation algorithm. Next. Implement algorithm that capable to deliver system that can accurately determine ECG wave characteristics. Next. And why it is better. It delivers promising accuracy and time computation performance inside limited memory of technology. Next.
So this is the project flow of our project, the flow of our project. First, the raw signal that include the noise will be inputted into the MATLAB for the denoising, and after that, after the denoising, there will be 2 files that include the files for the ECG P and T wave and QRS complex, and put it into the solution on the executable C language that will be include the squaring, creating moving average window, and detect each wave characteristic. And then based on that, there will be implementation into FPGA SoC and in the PC environment for the comparison to compare the computation time. So here, first the pre-processing part in the MATLAB is the signal will be using the discrete wavelet transform to decompose the signal into several levels, and from that there will be a reconstruction based on the which frequency that we need, which is 10 to 50 hertz for the QRS complex, and PNT wave using 0.6 and to 7 hertz. And from that two files will be input into the C executable solution. This one is in the C program that there will be a squaring, creating two moving average window with different size for the comparison between P and T wave, because it has different characteristic, and then create the detection for the both points, and the result will be in the P peak, onset and offset. So after we successfully create the solution inside the PC environment, we implement it into FPGA using the HPS, hard processor system. From there, we create the hardware design, configure the HPS peripheral and standard peripheral, and then we prepare the firmware development, created the preloader, and configure the Linux kernel, because inside the FPGA we use the ARM SoC. And then the last one, software development, compile the C source code inside the ARM SoC inside the Linux, and upload the binary file and kernel module to the Linux target board, because it has a different architecture with PC environment. So this is the result after we finish the computation inside the FPGA. We put it back into PC for the observation verification. This one for PQRST peak. So in here, as you can see, there is a point. It successfully detect the point for the peak, and the P onset. This one the before and after the peak, and this one for the T onset and offset for the before and after the peak. So based on that, we use dataset from the MITB pconet.com. We use the Qt database, and we take six dataset for the performance evaluation. From there, we achieve that the accuracy is above 90%, which is a very high. And then because inside the dataset it is 15 minutes long ECG record, we calculate for the 10 seconds computation, we achieve that for each 10 seconds of ECG record, it took 1.16 seconds computation time, which is very low, and it is suitable for the real-time application for the further development.
For the FPGA's algorithm features, there are three of them. The first one is high accuracy, instant computation performance, and the last is FPGA's allow system upgradability. Next.
By the end of these presentations, I would say that our project benefits has potential to be integrated with other arrhythmia classifications algorithms for home-based heart rate monitoring device. And also our product can be decision support system for non-specialist medical staff, and also can improve work efficiency and effectiveness during performance the heart screening, particularly in primary healthcare center. Next. So that's all from our group. Thank you very much for your attention.
Okay, So thank you very much for your presentation, for your effort in doing this project. I think it's quite interesting. It's an interesting project actually because we are using the given board by Intel, right? This current board used in the embedded system. Yeah. Okay. So I open to judges if you have any comments or you want to ask some questions to this group.
Yeah, I have one quick question. With regards to the performance data that you show us, that table. So did you ever compare that data against any commercially available data to basically benchmark or to tell exactly whatever you have implemented with your algorithm is actually better than what we have on the existing market?
Because this one is not yet become a device in the market, so I will compare it with the other paper publication. So in here, from the previous works of research, the computation time is about around 70 seconds for the same 15 minutes long. But for this one, it took more than that. Is 105 seconds for 15 minutes ECG records. But for the previous research, it's only detect QRS only. But this one is can detect all of the characteristic QRS and the peak and the onset. So that one is our justification. So, but for the if we want to compare with the same feature, it's not yet in the market, not yet in the paper. So from here you can say that it's much it has a higher capability, although it has also higher computation time, but the justification is for the each 10 seconds we can achieve 1.16 seconds computation time.
Okay, so thank you. Hopefully, I mean, you have answered the question from the judges, the judge just now. So any more questions?
Hi, teams. I was just trying to understand. So you did mention that high accuracy. So on that part, what are the tools you use to get the acquisitions? Is that some medical grades items, or what other item is actually being used?
You mean how we calculate the accuracy?
The first thing is what is the instruments that you take to get the ECG graph? Second is how you compare the accuracy towards.
So we take the data set from the medical database. So from there is a file, annotation file that we can compare. So and we compare it based on there is a standard, an international standard for the ECG wave, for the wave points performance evaluation. So we use that. We refer to that standard.
Yeah, you probably should have mentioned that in your presentation earlier on.
Hi, yeah, I do have a question as well. I think overall before that, good job to the team for pulling this off. I think FPGA is definitely not easy to deal with. So the question that I have is, I do know that with your project you achieve 1.16 performance data, right? Seconds. Did you try without the FPGA, and what is the data that you are seeing? If let's say you just use microcontroller or you use other hardware.
Currently, we only use the FPGA to test the performance.
Okay, I see. Okay, then no problem.
And also from that, we can only test with the 15 minutes long ECG records. So from that, we just assume that we calculate for how about the 10 seconds. So we didn't actually create the 10 seconds frame of files, no, but we create the 15 minutes and then we calculate for the 10 seconds.
So you mean you derive the 10 seconds from the 15 minutes data?
Yes.
Okay. So does that mean, because I'm trying to understand how the data came out, right? So after 10 seconds, you will wait for 1.16 seconds to process, or everything is running in parallel. So when the data fits in, your processing already running.
Oh, so the files is array file for the 15 minutes, and we directly input in the program and calculate it, the output for the 15 minutes result, and from that we calculate for the 10 seconds, because we only achieve the 105 seconds for 15 minutes. Then how about 10 seconds? 10 seconds of records. So actually the data set is already 15 minutes long. So we
Okay.
put directly.
Okay, thank you.
Yeah, maybe one other question. Just based on what you explained earlier on, looks like your project is more towards encoding and maybe decoding of the algorithm for the ECG implementation. But your title of your project, you also mentioned about the SOC design, aside knowing that the sits within the FPGA. So what exactly are you focusing on as part of the SOC design?
From that we prepare for the HPS, and the Linux inside the FPGA. So
okay, so that would be the software part of it, right?
yes.
What about, yeah, so your SOC design, you're actually referring to the software implementation?
Yes.
Oh, okay,
So
sure. Thanks.
for the future recommendation, there is also we can combine it with the hardware, because this one is only using HPS. So there is much more room for the development.
Okay, sure, noted, thanks.
So maybe one more question, right? So if there's one thing that you want to improve for your project, what is that gonna be?
One thing we can improve to using because this one is only using software implementation. We expect that the next development can be with the combined with the core hardware and software, because this one is only using the HPS. So for the future, it can be using the FPGA part. I mean the hardware part.
Okay, good.
Any more questions? Still have time, about 2 minutes. Okay, so if no more questions, thank you very much to Dehan, Mutia, and Naufal. For me, you have a good presentation, and confidence answer to the judges' questions. Okay, so hopefully you can continue this project for next level with master degree. Because for me, it's a good for you to explore more about this board lah. Okay. Thank you to all of you again.
Thank you, Madam.
Okay. So without any delay, I would like to invite the next group, which is from a group number of MY 147 from USM.
Hello, doctor. Can you hear me?
Yeah.
Okay, so I would like my team member to share their screen.
Can you guys see the screen?
Yes.
Yeah.
Okay, thank you.
Okay, so good day to Dr. Zani and all the judges. We are from group MY147, and my name is Yap Chun Yong, and that's my team member Pang Yushen and Teng Xiu Ming. We are from USM, and also our advisor is Professor Dr. Zani Abdul Halim, and our title will be Car Plate Detection System using hardware software partitioning. Okay, next.
Okay, first, why car plate detection system is important? This is because it can efficiently assist human in reading the car plate number, and also it play a significant role in the traffic law enforcement to ensure the safety of our road. So this system actually can be widely used in the shopping centers, country security, and most traffic related application. And currently, the solution implemented in the car plate detection system is either by a pure hardware or pure software. However, there are pros and cons respectively, right? So if we want to increase the accuracy when accepting an information, the resolution need to be higher and more data need to be processed. Hence, we might face higher resource and higher time consuming in the car plate detection system if we continue using either the pure software or pure hardware. This is because by pure hardware, the time consuming might be shorter, but a large resource consuming might be faced, while by pure software, it might take higher time consuming. So in this project, we are looking for a solution to provide optimum time and resource. And embedded system can help us solve this problem as it is the combination of hardware and software. So our objective in this project is first to develop a car plate detection system, and this system is developed by using pure software and pure hardware respectively. This is because we are able to determine the time consuming for each software and hardware for the further use. And the second objective is to perform hardware-software partitioning using genetic algorithm. As per mentioned in the problem statement, embedded system will provide us a better solution. Hence, we decided to build an embedded system to verify it by using hardware-software partitioning. And lastly is to investigate the performance of hardware-software partitioning in terms of processing speed and resource consumption, so that we are able to get the optimum time consuming and resource.
Okay, so for this project, we are using the board of D1 SoC. Okay, next. Okay, why we are using the D1 SoC board is that because D1 SoC is one of the CPU FPGA hybrid embedded platform, and which consists of HPS and FPGA. So HPS is software and FPGA is hardware. So that's why we can apply the hardware software partitioning here. Okay, next. So what is hardware software partitioning is that it is used to decide which process will be executed in hardware and which process will be executed in software. And for example, there are three examples for this hardware software partitioning, which is the integer linear programming, ILP, simulated annealing, SA, and genetic algorithm, GA. And we are using the GA. And GA is actually reflects the process of natural selection, where the fittest individual in a population are selected for reproduction in order to produce a better offspring in next generation. Okay, next. So why we are using genetic algorithm but not ILP or SA? So here's some basic introduction for ILP and SA. ILP is actually a method to achieve the best outcome, such as the maximum profit or lowest cost in a mathematical model, whose requirements are represented by linear relationships. And there's constraint for this ILP, which is the unknown variable should be in integer. But in our case, we are trying to get the execution time, which is not integer. So ILP is not really suitable for this case. And SA is actually the probabilistic technique for approximating the global optimum of a given function. But there's one constraint for SA, which is it needs many variables subject to several constraints. And why we are choosing GA is that GA supports multi-objective optimization, which is in our case is execution time and also the resource. So next. So to apply the genetic algorithm, which is the GA, the image processing will be separated into 12 tasks, as you can see in the table, which is the load image, crop image, all the way until the extract of the couplet. Okay, next. So there are some steps of this project, which is the first step will be the image processing. We will build the image processing using the C++ language with OpenCV library. After that, we will imitate the C++ code of image processing to C code for HPS, and also we will imitate the C++ code for image processing to Verilog HDL for FPGA hardware. And we will get the result of both time for HPS and FPGA, and also the resource for FPGA. After that, we will build the hardware-software partitioning, which is the genetic algorithm using the MATLAB. And after that, we will implement the result of time and resource into the genetic algorithm, and we will get the result in the form of position, time, and resource. So for the next step, in step 1, the image processing will build in C++, and the function will be separated according to the top step from the previous slide, which is the load image, crop image, all the way until crop the vertically. Yeah. So there are some user-defined function in our project, as you can see here. And after that, we will get the result of C++ image processing. As you can see in the picture here, we will get the source crop, gray, binary, remove plate, all the way until we crop the plate. So now I will pass back to my team member, which is Yushen, to continue the coding for HPS.
Okay, thank you. In this part, we are going to collect the data in HPS, and the data actually is the running time taken for the each task, and this is a C code used to implement in the HPS. So first, the C code is compiled with a make file together, and after compilation, the compile file has to be transferred into the SD card on the Adera D1 SoC board. So to transfer the compile file into the SD card, the IP address is identified, and the secure copy command is used to copy the executed file into the SD card. And then after all this done successfully, the code can be executed in HPS, and the result is shown here. Yeah. I will pass to Teng Xiu Ming.
Okay, thank you. Now let's take a look at the data collection in the FPGA for our implementation in the hardware. So Verilog HDL codes are written, and what you see on the screen now is the Verilog HDL code for the main module. Next, please. And the next one is the module 1 to load the image. Next. This is the module 2 for the image cropping task. Next one. And this is the module 3 for the conversion of RGB image to the grayscale image. And the rest of the image processing modules are not being shown here. Next, please. And now what we see on top part of the screen is the Verilog code for the multiplexer module, and the bottom one is the RAM module 1. Next, please. Next, these are the RAM module 2 for the 280 × 360 image, and the general RAM module 3 for the rest of the image processing task. Next, please. Next, the resource consumption of the FPGA is collected, and the total resources of each image processing node is obtained by adding up the logic utilization, total registers, total pins, and total DSP blocks. And the total resources consumed is 2,576. Besides, the waveform is observed in the ModelSim software to obtain the execution time of each node, and this is the example of the waveform. Next, please. Next. The execution time are based on the status of the enable signal, and for the example on the left, the clock 1 is the starting time of the first image processing task, and clock 2 is the end time. And after that, the execution time for each image processing nodes can be calculated based on the equation shown on the screen, and the total execution time is found to be 78.96 milliseconds. Then the execution time of HPS and FPGA are passed to the genetic algorithm code from MATLAB. And this is the MATLAB code for the genetic algorithm. And the result of position, time, and resources are obtained after running the MATLAB code. And comparison is done among the three systems, and the implementation of both HPS and FPGA has the shortest time, which is 72.3 milliseconds, and the resources consumption is 677, which is significantly lower than that of pure FPGA solution. And based on the result of the position of the nodes, the task of image processing has been distributed between the HPS and FPGA by the genetic algorithm. And in this table, the digit 1 indicates FPGA, while digit 0 indicates HPS. In conclusion, the carpet detection system is successfully built using C++, C, and Verilog HDL. Besides, the genetic algorithm is successfully built using the MATLAB with shorter execution time and lower resource consumption. And for genetic algorithm solution, the execution time is 8.73% faster than the pure hardware and 34.36% faster than pure software and 73.72% lesser resource consumed compared to the pure hardware. And as for future development, we wish to build the communication system between the FPGA and HPS to allow data transfer. And besides, improvements can be done on the code to enable automatic data pass between the FPGA and HPS. And furthermore, real-time camera can be applied on the system to be readily used by the public. And we would like to share with you the milestone of our project, which starts from the determination of car plate detection algorithm back in November 2020, and all the way to the report writing in June 2021. And now let's take a look at the demonstration video of our project. Thank you.
Yeah, so that's all from us. Thank you, everyone.
Okay. So thank you, Yap Jun Yung, Teng Siu Min, and Pang Yu Zwin, yeah, from USM. Okay, so thank you for your good presentation and your good effort for your video. Yeah. So I would like to open the any if you judges for the Q&A session.
Hi teams. Let me try to ask in the way that where did we actually see the car plate outputs? I don't really see the things come out other than the segmentations.
You mean our output is actually image and text file, which is you can see in the C code the image of the. I mean our result is in the image like you see in the C code, yeah. C++, yeah.
Okay.
And also our second result will be based on the genetic algorithm, the position, time, execution, and also the resource. Yeah.
Hi, team. Yeah, so just another follow-up question. So just based on what you have presented for the last maybe 10 minutes or so, it looks to me that there's actually a lot of the software work that actually went in, right? The HBS stuff that you guys mentioned, including the MATLAB coding and the Verilog and all that stuff, using the FPGA solution, right? Yeah, so I kind of like just wanted to understand by the hardware and software partitioning, um, is this only applicable for car plate detection, or why is car plate detection a specific use case here? Because it looks like car plate detection is going to be just one primary input, and then you're using your whole algorithm to process it, right? But it can also be applied to some other image processing algorithm or input devices, not necessarily on car plate. So kind of like just wanted to understand why specific the uniqueness in car plate. Maybe why,
Okay,
let's say
so
for example, maybe comparing this to maybe a facial detection or something like that, right? Yeah.
Okay, so one of the main reasons is that due to current COVID-19 cases are increasing, so we are hoping to build something that can help out in this situation, like how to let the government to control the movement of car. Maybe we put this system on any toll system to make sure the car are not going past, trespassing to any other states. So that's why we are trying to build it. I mean, using this application of car plate detection system. Yeah. Am I answering your question?
Yeah, partly yes, because I'm still also trying to understand, because there's already a lot of commercial solution available out there, right? Including what one of you mentioned about the CCTV recording all the happenings on the road, right? So with that solution in place, so what are the benefits that you're offering with your implementation? I mean, do you expect this to be deployed in every single street junction for the car detection eventually?
Hopefully yes, but because this system is not fully built yet, but I hope eventually it can be built in all the street throughout the Malaysia. Yeah.
Okay, sure, thanks.
Yeah, so let me ask a question about maybe more on FPGA. But before that, again, I want to say good job to the team for making this effort. I think this is very good. You have MATLAB, FPGA, and C++ code. So the question that I have is more on the input and the output for the FPGA, right? Because I do see you in your presentation you shared some of the coding for the FPGA. You have you crop the image and things like that. Is that image like a fixed data set that you acquire on, for the car plate, or is it something you capture from your car, just one image? How does that work? And then what is the output that the FPGA process, that give to the HBS?
Okay, so for the input, we are actually capturing some random image, and then after that, we will use the image to put into a code from MATLAB to convert it into the RGB value, and we put it into a text file, and then we process the text file in the FPGA. After that, we will print out the output will be the image that we process. Like first step, we are cropping the image. So the first step output will be the image crop. Yeah, something like this.
Okay, so you're using the FPGA to crop the image, is it?
Yeah.
Okay, so that means from the there's no like raw frame buffer from the camera for this project, right?
No. So that's why we are having a future improvement that mentioned about we are hoping to build this into the real-time camera so that we can capture the capture the image from the real-time camera. Yeah.
Okay, okay, thank you.
Yeah, maybe one other side question. Have you ever considered what if the image is distorted, or maybe during rainy days, or maybe the couplet is of a different dimension? Maybe italic, maybe bold, for example. So have you also considered that situation, or this is only purely the ideal, the best case?
We are doing the ideal, but we also did consider about the other cases like the italic word, like rainy day or maybe at night time. The accuracy of the system might be decreased, but it will not like decrease significantly.
So you also have that data in your project. That's what you're saying.
We did have some data with different car plates. I mean, different type of image, like maybe the black car, the white car, and also the number plate is different color, like yellow color. Yeah, we did have those kind of image. Yeah.
Okay, sure, thanks.
Yep, here, Harisan here. I do have one question regarding the validations. Your result that you shown based on how many data set, that means how many pictures of the car plate number that you have captured and validate on that?
We did try like 5 pictures, and all the pictures we run for like 10 times in order to get an average result.
Okay, so that is only applicable on a local car plate only, right?
Yeah.
Okay, got it. Thanks and good job.
Okay, thank you.
So, is there any more questions from judges?
Sorry, I got one question. What is the, I mean, like the advantage? I mean, like if you compare your system to the current ongoing plate this kind of system on the market right now?
Vishen, you want to answer it?
I just now have mentioned that currently the solution implemented for the carpet detection system is just only pure software and pure hardware. So there's pros and cons respectively, right? Regarding the pure hardware and pure software. So in our project, we are trying to use hardware and software partitioning. Means that combination of hardware and software. So it might take maybe a shorter times and better result compared to current carpet detection system. Yeah. That's why we using the embedded system because of the combination of software and hardware. Yeah. Yeah.
Okay.
Thank you.
Okay, so I think the group have answered the questions. So any more questions from judges? Okay, so if there's no more questions, thank you very much to Jun Yung, thanks you Min, and also Pang Yuzwin, yeah, for your presentation and also for your, Q&A, yeah. Okay, so next, I would like to invite the next group. It's from MY 180, where the title is the development of smart on-road surveillance system from Swinburne University.
Okay, testing. Can everyone hear me?
Yeah, can.
Okay, cool. Give me a moment. I want to just have a bit of a. How do I share my screen? Content screen. Okay. Can everyone see this?
Yeah, can. Please proceed.
Okay. So, hello everyone. So my name is Paul, and my teammate is Ton. So we're from Team MY180, and we are from Swinburne University. So I belong to a electrical background, and Ton belongs to a computing background. So for this competition, me and Ton wanted to venture into different fields, so we did a little switcheroo. So I'll be handling the user interface for this project, and Ton will be handling the electronics and AI. Okay, now on to our presentation. Oh, it's not working. Now, all right. So, ladies and gentlemen, the age-old problem since the invention of motorized vehicles, one that I believe some of us here have been the unfortunate victim of, car theft, or in other words, Grand Theft Auto. Did you know that in Malaysia a car is stolen every hour? 7,400 vehicles were stolen in 2020 alone. And according to the US, with the advanced surveillance and policing system, they were only able to recover about 50% of stolen vehicles. Just imagine, how about Malaysia? In Malaysia, existing smart visual systems are typically deployed onto fixed areas. However, some areas, especially those with increasing populations in rural areas, are unable to capture accidents or crimes without the implementation of video surveillance, which results in uneven security coverage between areas. So, this receives a vote of no confidence from the general public. And netizens turn to social media in the hopes of reaching out to the public, seeking help, and praying constantly that someone, somewhere, may have gotten a glimpse of their family car. But no more, for we have the solution. We propose a system where cars on the road can detect license plates, which will then be uploaded into our database. And should the car be wanted, it will raise a red flag on the map and alert the authorities so that they can respond swiftly. The Road Hero, a smart on-road surveillance system. Through a small survey, it would seem that the general public is in support of our idea, though some not without their concerns. One proposed that we remove unwanted license plates from our system. However, this would render the system ineffective, as there is usually a gap of time before the car is reported as stolen. It will be treated as a normal car, and it is usually in this gap of time that the whereabouts of where this car had been stolen is crucial so that the authorities can track it down. With this system, road users and car owners can rest easy. The authorities, especially during these trying times of COVID-19, will earn back the respect and trust of its citizens and make the streets safer for everyone. Let us make the worry of car theft no longer the looming giant it once was, but rather a trivial issue of the past. Ladies and gentlemen, we present to you the Road Hero.
So this is our system's overall architecture. First, we collect the data set, which is Malaysian dash cam footage, and we annotate the data set manually, which will then be used to train our deep learning model to detect the license plate, connections. So after the license model into the board, it will begin to detect license plates on the road using a dashcam and store them into our cloud storage database. Which is so the uploaded data will collect number, the GPS location, and the timestamp. As it is now, no actual video footage will be stored in our cloud database. So we use once YOLO algorithm for the detection of the license plate from the dashcam input. The YOLO algorithm is a deep learning algorithm just like other object detection algorithms. We choose to use YOLO because of its speed and accuracy in detecting objects. So as for the license plate character recognition, we use the Python Tesseract library. So Tesseract is an open source text recognition OCR engine. It is used to recognize and read the text embedded in image. In our case, is the license plate number.
Okay, so the database, the container which will store all of our data. It is designed with SQL and managed using SQL Server Management System software. Main records will store the timestamp, car plate number along with the location, or the car status will store 3 eligible car status to choose from, which are normal, wanted, and missing. The user interface is designed using ASP.NET MVC with C# and HTML as the language. So MVC here stands for Model, View, Controller, which sums up the design of the web application with the model containing multiple classes which store data retrieved from the database. And all this is made possible through the web hosting service Microsoft Azure, which connects our database with the user interface.
So for a quick demo, I'll show you how our system works. From the video, we see that our license plate detector has successfully detected the license plate of the vehicle in front. So after the license plate is detected, the detected image is preprocessed by inverting the white part and the black part of the license plate to black and white. And then the Tesseract library is used to detect the license plate number. So in this case, the license plate detector is VCF608, which is correct. Finally, the license plate number, the location, and the timestamp will be uploaded into our cloud database.
Okay. So the user, or in this case, the authorities, will be able to navigate around the map as one would in Google Maps. Below the map is a list of records retrieved from the database, and they will be able to pin and filter any car or car status that they wish, and pin the timestamps or location of interest, which is paramount in tracking down missing cars or wanted vehicles.
So we tested our model, and the mean average precision score we achieve is 76.8% with intersection over union of 0.3. The performance of this detection model is expected to rise with more testing images being used to train the model. However, due to limitation, only a few hundred images were used. As for character recognition, from the result table, we found out that the closer our dashcam to the vehicle in front, the better the performance of the license plate recognition.
So in conclusion, our project is one of the alternatives that will provide the future for Malaysia to venture into a smart and safe city by expanding not only the coverage in well-developed cities, but also in new developing areas, based on the strengths of citizens through a mobile visual security system. So, to wrap things up, I would like to show everyone a demo of our project in action.
So we see that from here.
Oh wait, sorry. There's no sound being played. How do I share my sound? I'm sorry. How to share sound? Share content, include computer sound. Oh, okay, I see it now. Okay.
Latitude, longitude, and timestamp. This data will be pushed to our cloud database.
So, first things first, we must log on to our website. Okay, we keep records of all the car plates that have been detected thus far. And if you would like, you can start pinning some of the car plates onto the map. So initially we can see that this wanted car started out from Swinburne and it starts to move along upwards up to New Atmosfera and is moving down towards the roundabout and towards King Center into Jalan Tunjungan. Let's see where it's going next. We know that the car's final destination as of this time and date is at Noms, Malaysia. In general, we can pretty much sum it up that someone stole the car from Swinburne University of Technology and decided to park it at Noms, Malaysia. This is how the police or the authorities can track down wanted cars from our road detection system. All right, and that is all from our team. Thank you very much for listening to our presentation.
Okay, so thank you for the team, Ton Poon Liang and also Paul Kernis Bong. Okay, so thank you for your good presentation and good effort for this project and competition. Okay, so I open the, question from judges.
Yeah, I have a question. Again, very good job. Please, very, very interesting project. So my question is, what is the Intel hardware or software that you use for this project?
Actually, we try to use OpenVNode for our detections, and we also try to use the upscale board for the hardware. But in the end, we did not pull it off very good, so we did not use it, the hardware and the software.
I see. Okay, yeah, because this is I think this is a miss, right? Because unfortunately for Intel track, if there's no Intel hardware or software use, it will result in disqualification.
I see.
Yep. But nonetheless, I think this is a very good effort and very interesting project. Yeah.
Thank you.
Thanks for putting in the effort.
Yeah, maybe Ton, can you elaborate more why the upsquare board and OpenVNO is not the right solution? I mean, it's also good for us to know what is the limitation, right, from both hardware and software that restraining you guys from deploying that.
Okay, so we want to talk about the upscale board first. We trained I think there is a TensorFlow version problem in our development and on the upscale board. So when I want to put my so I'm developing in Linux OS as well. So when I want to move my model and all of the codes to the upscale board, I receive illegal instruction error, which I tried to solve it, and it didn't end well. And as for OpenVNO solutions, it happens as well. The same thing happens as well.
But Ton, if I remember correctly, you started your project with this upsquare and OpenVNO before, right?
Yeah, I tried it, but the whole development is on my own hardware, on my own system.
Okay, but the first round of the presentation that you've made, if I remember correctly, in one of your presentation, you do include upsquare and OpenVNO mentioned in the first round of the presentation.
But I think the one is still under development stage. So we are trying. We tried and we plan to use it as well. Yeah.
Okay, understand. Okay, sure. Yeah.
Yeah, but your own system, is it with an Intel inside?
development environment for the project is in Linux OS and it's Intel as well. The CPU is Intel as well. Do I have any more questions?
Okay, so any more questions from judges?
Yeah, maybe just one follow-up question. So just based on the ASP and also the GPS UI that you guys share, right? The last demo, where you basically show, I don't know, 5 or 6 location, right?
Correct.
Of that car 608, right? So that is also assuming that you have 5 or 6 cars behind that is actually capturing the license plate. It's not only coming from one source.
Correct.
Is that correct? And by the way, that is the GPS coordination of the car who is actually capturing the number plate and not the actual car that is being stolen.
Yes, that's the GPS on the location which of the board which will be installing in the car that will be monitoring the roads.
And it's not the car that is being stolen. It's not that car. It's the cars that is actually falling behind, assuming they bump into that stolen car by accident. And it got
Correct.
captured and got uploaded. Okay, understand. Thanks.
So because of our detection range, you will get a very close proximity to the car.
Okay, maybe just one more question. Just now you mentioned that you are having difficulty developing your solution with OpenVINO on upsquare boards, right? Then later on you move to your own system, could be a laptop, desktop, or whatever, right, with Intel processor. Have you tried with OpenVINO as well? On your desktop or on your Intel desktop or Intel laptop with OpenVINO software?
Okay, actually we tried it. So I'm the Linux environment that I'm developing in is having a very all Intel chip. So it's actually not supported the OpenVINO. So I moved it to my another laptop which is in Windows, and then the environment messed up. So it cannot like run the OpenVINO, the model conversion and other things. So I tried in 2 environments actually.
Okay.
Anyway, just now you use what? If you're not using OpenVINO.
We are using the model training for the license plate detection. We use you only log once algorithm, which is YOLO, and then for the license plate recognition, we use Tesseract library. Yes.
Yeah, yeah. So putting down the Intel hat, right? Just some question that, yeah, because I do really like this project a lot. If there's one thing that you can improve again, you know, what will you do for, you know, for this project? Is it like performance or maybe track the car next and or something like that? And how do you plan to commercialize it? Is it like a car cam factor or something else?
Okay, so okay, I think I can handle this. All right, so initially we intend to install this on cars so that we can have a wide coverage range. So perhaps we can get a partnership with like Grab, saying that Grab can make the city a safer place as well. And because of Grab, it's very widespread. We can also get a lot of coverage in that. And regarding improvement, one, we could further improve the UI because it's still under development. And after that, we intend to branch out to testing the license plate recognition under many different kinds of conditions, like weather conditions. So I'd like to let Tom to further explain on this.
Yeah, I think one of the judges mentioned license plate recognition in under many circumstances. Like the license plate is comprised with many different kind of font, the italic and bold, and in different colors as well, in different weather conditions as well. This is what we did not achieve in this project, but it is in the in the plan for the future, and we are trying to focus on the Malaysian license plate only. So with our system, we can collect a lot of data, and which will not only be used for car theft recognition in the future. We can also do a lot of analytics project as well as detection projects on the road as well, on the city as well.
And
Yeah,
sorry.
I think that is a good answer, partnering with Grab, right? I'm actually thinking a little bit on the waste side as well, because this is more like a crowdsourcing kind of concept, right? The more user uses your system, the more ways you can track missing cars. But if let's say no one uses the system, then it's very hard to track, right?
Yeah.
So I think waste is a better go-to if let's say you can talk to them and maybe offer your service as a as a first freemium, and then after that, yeah, you start charging them. But yeah, I just said don't get discouraged, if in this case where there's no inter-element. But this is still a very good idea. So yeah, I do hope you all can continue and expand on it. Yeah, just my 2 cents.
Thank you.
Okay, thank you.
Okay, so thank you, Tuan Pung Leong and Paul Cornelius Bong, for your good presentation and good idea in this competition. Okay, so since we only have 15 minutes left, right, because we will end at 11 o'clock, I would like to invite the next group, which is from MY243, to present their project. The title is COVID-19 Mandatory Self-Quarantine Wearable Device for Authority Monitoring with HAI Reporting and Flagging System. Okay, welcome.
Okay, all right. Hi, everyone. So let me have a share screen now. Sorry. Okay. So you all can see my screen or not?
Yeah, can. Please proceed.
Okay, so I will start my presentation now. And hello everyone, I'm from team MY243, and today I'm going to present about my project which titled as COVID-19 Mandatory Self-Quarantine Wearable Device for Authority Monitoring with HAI Reporting and Flagging System. So before I start my presentation, let me have a simple introduction to myself. So my name is Lim Wei Jie and currently taking a Bachelor of Electrical Engineering major in Power System from University Malaysia Pahang. So let us focus in my project, which is the current solution that available in Malaysia nowadays. So we can see that nowadays the government has proposed or set a rules that for anyone that returning from overseas to Malaysia, that need to have a 14 days mandatory self-quarantine. And we can see and realize that now commonly or usually the government will provide a pink wristband for those who need to undergo this mandatory self-quarantine. But there is a lot of bad impact or also the disadvantage for this pink wristband solution. So one of the disadvantage is we can see this is actually totally free from restriction. There is no under any control, no under any supervision by the authorities. So it means the person in quarantine can go to anywhere and it can decide to go to anywhere because there is no any control under the authorities. And secondly is there is depends only on self-discipline. So means the individual can easily to disobey the rule if the individual don't have the self-discipline. So we can see there's a lot of issue or news that happening in Malaysia. So this is one of the issue that is the Kedah Sivaganga cluster occurring in last year August. There's a male restaurant owner who just returning from the Indian, but he broke the home quarantine rules and causing the COVID-19 virus spread around the Kedah until to the Penang and seriously until to the police. So this made a seriousness issue that causing in Malaysia. And not only from the Kedah Sivaganga cluster, we can see there's a lot of other issue like 2020 of March, a Penang man in pink wristband seen in the hardware store. And just occurred in last 2 months, 2021 June, a man in pink wristband seen in the Malacca mini market. And also the last year, July and August, there are a lot of these non-adherent cases occurring in Malaysia, which lead to the increasing of COVID-19 cases in Malaysia. So we have proposed our solutions, and now let's enjoy our solutions that how we solve this issue. So enjoy this video.
But how this issue will be solved, we will propose a comprehensive system towards this issue. For the quarantine user, we have proposed a HESM application as well as a tracking wearable to monitor the movement of the quarantine user. For the non-risk user, the C-Trace application is developed as to trace and report the quarantine user wearable if non-adherence occur. For the authorities, a HESM monitoring dashboard has been designed, and with the power of the OpenVINO, the dashboard is able to integrate a face recognition system as identification for the quarantine user when using the application. Let's start the demonstration with the first registration part by using the HESM monitoring dashboard. The user information can be registered through the HESM monitoring dashboard. A photo is required to upload for the quarantine user. Each user role will show the quarantine day left, the face recognition, wrapper button, health and location status button. Once done, the authorities need to run the first time detector to register the face into the engine. After the crop picture appears, means the face data is registered. The wearable consists of one microcontroller, two BLE module, and one pulse and blood oximeter sensors. Here's to explain the use of two BLE modules. One of the BLE module is mainly responsible for transmitting the sensor data to smartphone, and another one is always discoverable for the public as the function for the C-Trace application. Before the user start the application, open the Bluetooth and pair the wearable. Once paired, and you are ready to start the HESM. Log in by using the given username and password during registration. The main page consists of historical data column, quarantine data section, main periodic check now button. Run the check now and start the checkup cycle. First, the application is required the user to upload a selfie photo. After the upload button click, the photo will directly send to the HESM monitoring dashboard, and the face recognition indicator will change from green to yellow. Clicking the yellow indicator button, recognition will run. Once done, the indicator will change the color. The green colors means the result is matched. Continue with the health checkup. The users are required to connect the wearable and check the health status. And last, end with the location checking. And continue the checking cycle with further notice.
I think I can bring the wearable and also smartphone go to my other friend's house ma. I can also perform the same checking step at my friend's house. Okay, go out with the wearable and also the smartphone.
When the users go out with the wearable and the smartphone, the non-risk user with the C-Trace application is able to sense the wearable within 2 meters. Once the application sends the wearable in 2 meters range, the application will trigger notification. The notification will prompt out even the application is not open or run in background. Click the yes button, the flag will directly send to the authorities, and the button of the user changes from green to red, and the authorities can check the detail of this report.
Since I wear this wearable, the others can tracking me. So I just tear down this wearable and then I bring smartphone only go out. Also can, right? Okay. Bring smartphone only.
When arriving to the health checkup stage, the skip button will prompt out instead of the next button because the wearable is not connected. If the skip button is clicked, a flag will be made to the authorities.
Skip will report. So I think I just remain this page and then I go home, wear my wearable and then continue to scan.
Regarding this issue, if the user not complete the checking cycle within 10 minutes, a flag will be sent to the self button and the self button changes from green to red.
Since I do everything also can track me, so I just pass this wearable and also a smartphone to my sister. I don't think the system is so intelligent can recognize me. Okay, I just pass and I go out.
During the face recognition, the user still can upload the photo and continue the checking cycle. But at the authority side, once a new photo is uploaded, the authorities will run the recognition. If the image uploaded is not matched, it will give a red flag instead of green flag, and the result is not matched. And this is the comparison between the current solution, which is a quarantine person only using the pink wristband, and this solution for the quarantine person is totally free from restriction, and all it depends on the self-discipline. While another solution that has been released in some country by using the GPS-based wristband. And this solution is restrict the movement of the quarantine person, but it will having lots of error and inaccurate report from the wristband. And our solution have been getting the effort and cooperation from quarantine user, normal citizen, and the authorities. A HISM application for quarantine user will always checking the status of the user by using the wearable, and the normal citizen can help authorities to track the movement of the quarantine user. Hence, the movement is totally restricted, and the system is easy to investigate the non-adherence issue. And that's all from us. My name is Wei Jie. Thanks for watching.
Okay, so let us continue to the presentation slide.
But how this issue will be solved?
Sorry. Okay, so let us focus on our solution. So this is a system architecture that we created our own and designed for our own, and it is new in the market. So the system architecture is actually separate into 3 parties, as mentioned in the video. So which is the quarantine user, non-risk user, and also the authorities. So for the quarantine user, we have prepared and designed application that called HISM. So this HISM is need to combine with our wearable with the BLE technology, and after this, all the data will be transmitted into our created database. And same with the non-risk user, the C-Trace application data will always sense the wearable, and the data will be transmitted to the same database also. While for the authority side, the data will be retrieving from the database and showing properly and nicely in the HISM monitoring dashboard. It means we will not show the raw data from the database to the authorities. We will create a sorting and AI smart system in our HISM monitoring dashboard and show it nicely to the authorities. So let's get into the quarantine user application, which called HISM. So HISM is mean healthcare, isolation, and monitoring. And this application is created by using the Android Studio and also PHP called collecting and posting or retrieving data from the database to the application. So next, the HISM application is actually a very user-friendly interface. We designed it. So as shown as this figure, we can see that there is a guidance animation here. For example, now when you're entering into the application, the guidance animation will guide you which one you need to click. Like this one, first one, you click the tag photos. After you click the tag photos, the guidance animation will guide you. Oh, after this, you need to click the upload. And after this, you need to click the next. So this can lead to, it's very easy for elderly or kid even can read or understand English can use our application. So this is why user-friendly interface that we created and designed for all level of citizens can achieve our application. And not only for this, and you may wondering, I have a question about, how about if I'm in sleeping? So we have provided a sleep mode that is only available from 10 p.m. until 8 a.m. For example, now you need to sleep on 10 p.m. So you can set the timing until the 8 a.m. So when you settings, the flagging will not enable and the reporting will be disabled and just track the location of the quarantine user. Okay. So next, go to the non-risk user application, which is called the C-Trace, which is the isolation wearable tracing apps. And this is using the same development environment, same with the HISM application. And this application is mainly for the non-risk user to track the quarantine user wearable. Okay, so let us have an overview about the quarantine user wearable. So our wearable is built with the biodegradable filaments, and also these biodegradable filaments is to ensure that the casing is very environment friendly to the environments, and it is actually safe to use for the next user. It means the casing need to replace the new one when we're giving to the new or the next quarantine user. And this wearable is actually complement of the reporting system. It's empower and giving the extra point for the quarantine enforcement. Okay, so next is about our HISM monitoring dashboard. Okay, so as shown as the video, this monitoring dashboard is actually a very AI and provide a smart indicator that the authorities don't need to check one by one. And it will automatic sorting based on the open result and also the non-adherence occurring in the application. Okay. So let us move to the HAI face recognition, which is using the OpenVINO powered by the Intel. So this function is plugged into our system is to make sure that the issue of replace to another is not occurring during the quarantine. So we do not use the fingerprint identification or the face recognition locally in our smartphone. So we use the OpenVINO, which means all the images were uploaded to the server and undergo at the edge device side. So the face recognition is actually undergo at the authority side, not undergo in the locally smartphone. Okay. So this is what the OpenVINO looks like. The OpenVINO usually need to trigger at the Linux terminal or the CMD. Windows is quite complex and needs some professional who have a knowledge of the OpenVINO can trigger out. But we transform this engine and make it can be as an analysis engine in our UI. So it means we create a beautiful UI that can be accessed by any level of the people, of the users, which don't have the knowledge about the OpenVINO, still can using it. So this UI consists of the smart sorting analysis. It will, based on the uploaded image and sorting based on the respective user, and undergo the analysis from the OpenVINO at the edge device side. And this is very easy and convenient to use. And based on this, the smart indicator will changing based on the result inside the OpenVINO windows, which means this indicator will change either green, which is the result is matched and no incoming photos, and either yellow, which is available incoming photos, and either after the checking recognition, it will change to red also, which is the found not matched result inside the OpenVINO engine. Okay. So why are we using the BLE instead of other types?
Sorry, Mr. Lim Wezi. Actually, you have 1 more minute to finish because you are given 15 minutes for
Okay. Sorry. Okay. So can I jump to the last slide? Sorry for that. Okay. So let us more focus on the market comparison. So our solutions have been, we can see there's a lot of quarantine application compared to the others like Hong Kong, South Korea, and also Poland. But our solution have been fixed all the possibility and all the functionality that can be enforced the quarantine rules. So it means we have plugged in the individual identification that not available in Hong Kong and also the South Korea, and also the AI report and flagging system in our whole system. So this means we can give the authorities more convenient and easy way to track the non-adherence issue. So that's all from my presentation. Thank you very much.
Okay, so thank you, Lim Wezi. Sorry for interrupting your presentation.
Yes,
because I'm worried. I believe judges have a lot of questions for your project because you're discussing about the current issue, right? The COVID-19 issue. So I open to judges for questions. Question and answer.
Yeah, so maybe can you quickly explain again how's your implementation of your OpenVINO at the backend in terms of the facial recognitions and so on?
Okay, so actually the OpenVINO, we are using the PHP scripting. So we running the OpenVINO at the HTML side. So when we clicking the HTML side, we use the PHP scripting to figure out or trigger out the OpenVINO automatically at the edge device side. So actually the input is from the application, we upload the photos, and then the photo will be undergo an analysis from the edge device side and give the result at the HTML side. So this is the overall how the OpenVINO is going on.
Okay, and what's the machine you chosen to run the OpenVINO?
Yes, it's an Intel-based computer. My laptop is Intel-based computer, which is the 11th generation Intel.
Okay, that's quite new. It's quite powerful. All right, thank you.
Yeah. Hey, go ahead.
Yeah. So sorry about that. Yeah. So just I think this is probably a well presented material. I think you have done a lot of good research, including comparing the practical solution from other country. So maybe some added advantage on that. I wanted to touch base where you stop because you are running out of time on the BLE, right? So yeah. So the BLE today, I believe you also know that it operates at 2.4 gigahertz, right? It's the same frequency as our Wi-Fi, and the one thing I wanted to know is that because the low energy for that Bluetooth at a particular idle of time, it will go into a sleep mode. So that is one one line item kind of like wanted you to consider, right? How do you ensure that you still get an active detection? And then the distance is also limited to I think 1.5 to 2 meters, right? Anything beyond than that, BLE is not able to detect. So so wanted to hear from you, implementation.
Okay, so the first question is about the BLE module going to sleep mode, right? So this actually have a lot of software or driver to the BLE module. So it can be ensured that this is always activate, always been in an activated mode. So it means when you trigger with the driver or also modify the software implementation for the BLE module, it can ensure that the BLE modules is always powered up and always at the activation mode. So we have ensured that the battery life is actually can be fit to the activation mode during the 14 days of the quarantine. Okay, so for another question is about the BLE module. Sorry, can I ask another question? This one, sorry.
Oh yeah, I'm referring to the distance. The distance of
Okay, the
detection.
distance, right? Okay, the distance of detection actually we set is about 2 meters for the quarantine user. So within the 2 meters without any obstruction or any interruption, it is actually very accurate for the system. Yes, so we are not exceed the 2 meter range. We exactly is ensure that this 2 meter range can be sensed.
And that is provided the condition that the system is actually paired. But in case any of the disconnection happen in between, then this will not happen and you are expecting the repairing to be reinitiated.
Yeah.
Is that the right understanding? If let's say you move out of the 2 meter, the system will actually get disconnected. And then probably if you...
It's actually not get disconnected. It is like always discoverable. It's always discoverable out of 2 meters. So once it's attached to the wearables in between the 2 meters, it will discover the wearables. Can you get my idea?
Sure. Yeah. Okay, I
Okay.
understand that.
Yeah, it is always discoverable. It will not like suddenly turn off or suddenly in a sleep mode because the application already implementation to run in the background with the Bluetooth activation. So both the phone and also the wearable can be always in the activation mode.
Sure, noted. Thanks.
Okay.
Okay.
Yeah. So, yeah. So one question or rather feedback, right? I think your project is very neat, very concise, very end to end. So it's a good job for you. But it kind of reminds me of the inmate tracker, like those that the prisoner wears at the feet, and then it has a GPS modules that can track if let's say they are going around. I think the problem with that is that it doesn't have the vision capability like you mentioned, and then it does not have hard requirements on Bluetooth. Because yours, it had, if let's say someone who is positive COVID, it doesn't have a phone with Bluetooth capability, maybe they're using like the old 3310 kind of phone, then your concept will not be able to run, right?
Yes, this is one of the concern we have thinking before. But if for those who need to run the quarantine or we need to commercialize this system into the market, so the first consideration is we need to prepare a phone. But the phone is not cannot be not. It's not ensure that the phone is need to very expensive. It can be a very low spec phone, also can be run our application as well as the phone have the BLE technology, which is the BLE 4 above.
Okay. Because I'm kind of thinking from a practically perspective, if you have so many people who is positive COVID, it's a little bit hard to scale. Even the GPS tracking system that currently used for inmate is very expensive, $25 per day just to maintain it. So for your case, I'm thinking if let's say your module, I mean the band itself can emit some kind of like a Bluetooth signal to nearby people. So if let's say I'm the one who is the non-COVID, user, right? I open up my Bluetooth and say, oh, somebody nearby is, emitting the positive COVID's, Bluetooth signal. Then I quickly run away from the situation. I think that would be much, better than relying on the discipline of that of that positive COVID person. Yeah. But overall, I like your project. Yeah, good job.
Okay, thank you.
Okay, Wei Jie, so
yes,
this is not a question. So first thing, I actually very impressive for your projects and also your presentations, and good job on that.
Okay.
So my suggestions are also perhaps next level of suggestions that you can do is that perhaps you might wanted to minimize the design of your hardware, because what you can do is that, because right now we already have like the smartwatch and all these things available in the market, so you can actually use all these things as the hardware, as the replacement for your wearable band. Perhaps you might wanted to have your software or apps that can actually integrate into that smartwatch, and then you can actually use that as your alternative for your wearable, which will be saving a lot of cost and also your time, and this is my suggestions improvement on that.
Okay.
Good job. Thank you.
Okay, thank you so much.
Okay, so thank you, Lim Weiji. from UMP.
Okay.
Okay, so thank you, and I would like to invite the next project from MY244. The title is 2D OCDMA encoder decoder for various industrial application. You are welcome.
Hello. Can you hear my voice?
Yeah, we
Hello?
can hear.
Okay.
Yeah, we can go ahead.
Assalamualaikum and good morning, everyone. We are from group MY244. My name is Syed Muhammad Amal bin Syed Alwiya Junid. My team member is Muhammad Amirul bin Muhammad Anwar and Amirul Aiman bin Ismail. And today we will be presenting about our project, which is the 2D OCDMA encoder or decoder for various industrial applications. First, I would like to show our video presentation, which will give you a brief idea about the purpose of our project.
Alright, so now presenting about the video first. Okay, so can everyone hear the sound?
No sound.
No sound?
Yeah.
Go back
Yeah.
to the share content and turn on the audio sound.
Okay, how about now?
No sound.
No sound.
Share whole screen, everything, and turn on the audio sound. Include computer sound, mirror.
Yeah. Where is it?
Include computer sound. Add the share content.
So how about now?
Oh, no.
No. No sound.
So how about you present the video?
Okay, hang on.
You can proceed first with the presentation.
Okay.
Okay. Mm. All right. Share content, clear audio, screen. Okay. Can you guys hear the sound?
Yeah.
Alright. Today's global business demand faster, more secure, and larger capacity communication systems for their network operations. Fiber optic technology is expected to play a major part in this growth. Fiber optics are unusual to conventional copper-based data transmission cables, which have much compensation such as high bandwidth, little loss over long distance, and inherent struggle to electromagnetic interference (EMI). Optical networks are expected to provide variety of broadband service to customers. The network must require an increased bandwidth as well as the throughput. CDMA system can increase the number of transmission capacity of an optical fiber and supports wide and narrow bandwidth application on the same network. The demand for high-speed data transmission and encrypted communication gives us the determination to complete this project. The aim of this project is to develop a new 2D OCDMA encoder and decoder for highly secure transmission with implementation of FPGA as a code generator. OCDMA has been in the communication industry for almost 3 decades, where it has solved many communication problems. Now, we introduce the OCDMA system implemented with FPGA that is applied into various fields such as automotive, oil and gas, aviation, IR 4.0, and industrial automation.
Alright, as you can see, our project is about using FPGA with the OCDMA system to improve the existing communication systems such as TDMA and WDMA. Next, I will explain the details of the project through this slide. Okay, in this slide, it shows three types of multiple access technique, which is TDMA, WDMA, and OCDMA. In TDMA, each user is allocated by the time slots. The problem of using TDMA is that once the number of users is increased, it will cause a significant delay that will affect the performance of the system. While WDMA use wavelength for data transmission, But the problem with WDMA is it has a channel crosstalk, and the system is expensive due to using the optical laser source for the transmission. In OCDMA, we use code to transmit the data. By using code, it can be sent at any time without any collision. In this project, we will introduce the OCDMA system with FPGA as a code generator. So in OCDMA, code play a very important role. The performance of OCDMA system is depend on the code structure. OCDMA system can be either 1D or 2D code. The basic idea of the 2D signature code is to spread both time and wavelength, while 1D code can spread either time or wavelength. Nowadays, the most popular technique of OCDMA is using the 2D code. So we use a 2D FCC MDW code, which is the combination of 1D FCC and 1D MDW. MDW is used for the wavelength spreading, while the FCC is used for the time spreading. The table shows the basic code construction for the 2D FCC MDW. Based on the tables, each column represented by the wavelength, while each row is represented by the time. So our system, this is our system design in figure 1. Okay, our system consists of transmitter and receiver. As we can see in figure 1, the LED, encoder, and modulator can be classified as the transmitter, while the decoder can be classified as a receiver. The optical switch is used in transmitter and receiver, where it receives the code from the FPGA. So this is our design using the OptiSystem software. We design and stimulate by using the OptiSystem 11 version 11. This is figure 2, shows the 2D FCC MDW OCDMA system designed using the OptiSystem. At the left hand side, you can see it classified as the transmitter. At the right hand side, it classified as the receiver. So for result discussion, figure 3 shows the output code generator for the FPGA, and the right hand side it shows the code generator for the FPGA by using the oscilloscope. At the left hand side is for the simulation. So we use 50 MHz as a clock signal for the optical switching. Then okay, these are the performance of the 2D OCDMA system in terms of the bit error rate. So the bit error rate that we obtain has passed the maximum value of 10 to the power of -9, which is good. We obtained the 9.78436 times 10 to the power of -42. And with the Q factor for the first receiver is 13.4795. So because Q factor is important parameter to determine the reliability of our system. So it must be created and set for the error-free in optical communications. So these are our eye diagram for the from the receiver in figure 5, and figure 6 is the Q factor. We test the system according to the standard bit rate, which is 1.5 gigabit per second, and we also test it on 2.5 gigabit per second for the 50 kilometers. So these are the performance. We differentiate with the number of time spreading and the number of wavelength spreading. So as we can see, if we increase the number of wavelength for the figure 7, we increase the number of wavelength. It has a little bit significant difference, which is it can support a little bit more per user, number of simultaneous user. While when we increase the number of time spreading, it can support 350 and above for the system. So this we compare it with the 2D and 1D OCDMA. We have a 2D FCC MDW. We fix the number of time spreading, and FCC and 1D FCC and 1D MDW only use the wavelength, which is W equals to 4. We fix the number of time spreading is equal to 4. Then, as we can see, 2D FCC MDW can support much more number of simultaneous users rather than 1D FCC and 1D MDW. And this application for the 2D OCDMA for various industrial applications. One of the application includes the implementation in automotive industries. For example, recent development requires multiple sensors to be implemented in a car. By using OCDMA, we can reduce the use of copper wire, which will decrease the amount of EMI because we use optical fiber. Each code can be represented as a sensor. This will also increase the speed of transmission because shorter fiber wire lengths can be used. In aviation, the OCDMA offers a high-speed internet connection for passengers. As we know, it can also decrease the use of copper wire, which will decrease the amount of EMI, electromagnetic interference. Then we have fast train. Fast train can also offer a high-speed internet connection for passengers, which is the same as the aviation application. Now, okay, for oil and gas, the purpose is to decrease the risk of the faulty wire, which can cause the fire outbreak in the facility. When a spark occurs at the facility, the oil and gas can be ignited due to excessive usage of copper wire. By using optical fiber, the amount of copper wire can be decreased significantly. In terms of communication, the data transmission can be enhanced with better communication signal. It can also increase the workplace safety measure. And I think that's all for my presentations. Thank you for your attention.
Okay. Thank you, Syed Muhammad Ammar, Muhammad Amirul, and Amirul Aiman for your good presentation and your good effort in this project. So I open to judges to ask questions and for the Q&A session. Any question from judges?
Yeah. Hi. Thanks for demonstrating this capability. So I just basically have a question in regards to the CDMA implementation. So as far as I know, the multiple access, these are kind of like a modulation technique, right? Versus the one that you mentioned on the time division and also bandwidth division. And I believe that this technology is already in the market, at least for the wireless communication, maybe for a few decades already. And they are primarily using the CDMA because they kind of like wanted to avoid any collision of multi-user at the same time. So with this in mind, I wanted to know, on top of what you have already done, right, what will be the added advantage of your solution versus what is already in the market today?
What is the added advantages?
Yes, on the fiber optic solution, right? Yeah, that you mentioned. Versus whatever that is already available. I assume that you are using the primary fundamental technology of CDMA, correct? And then you
Yes.
are building, yeah. So I kind of like wanted to understand, maybe you can help me to summarize what will be the added advantage or what are the innovative idea that you have put in versus what is already available in the market that is also using the CDMA solution.
Okay, as we know, the TDMA is difficult to solve the synchronization of optical pulse, and it also have the limited time slot. Then for the WDMA, it has a fixed number of wavelength channel. In OCDMA, we use the codes to each user is assigned with different codes, with a unique code, which will it also like it can avoid the collision with each other, unlike the WDMA, which has the channel crosstalk. And TDMA, it needs a synchronization because if it has the number of simultaneous user, it has more simultaneous user. it will cause delay or scheduling. So the OCDMA will not have a problem with that.
Agree. But what I try to understand is that because this CDMA technology is already there in the market for some time already, right? It's not a new deployed technology. So I kind of like wanted to know what are you enabling on top of this technology that will give you the edge advantage versus the existing solution.
The CDMA is in a wireless because we're using the
yeah.
optical fiber.
Correct. Yeah. But comparing the optical fiber, right? What other added advantage that you are bringing in?
What other added advantages?
Yes.
Like because the other conventional system like TDMA and WDMA does not use FPGA for the system.
But they can use FPGA, correct? I mean, today they don't use, but they can also use.
Today they can also use. I don't think so. Because CDMA, like I said, it has time spreading and the wavelength. So we use the time spreading as the code, which we use the 50 MHz clock for the code generator. Because we use FPGA to generate the code. Because those techniques like WDM and the TDM, WDM it use a laser for the carrier. Because CDMA use LED for the data transmission for the carrier, and then it use the FPGA as a time.
Okay, sure. Thanks.
Teams. So can you me is it is
Hello.
Hello.
Hello?
Hello.
Is it okay? I cannot hear clearly.
try to repeat my questions. So what kind of medium that you use as the transfer for your modulations? If it is opticals, you mentioned LED is through air or through cables?
Through cable. Well, can you repeat the question? I didn't get what medium for the LED to transfer to the modulator?
Yeah, medium of transfer. You are mentioning OCDMA, WCDMA. Most of the time, those are wireless connectivity. But you are telling me that your LED is transferred through fiber optical cable, right?
Hello? Hello? We're using the fiber. Because we're talking about the high power LED for the communication. Hello?
Hello. So
Hello?
that means your answer is you are using LED, right?
Yes.
You are using fiber, right? Your source is from LED, right?
Yes.
Okay. So how about the judge? Are they answering your questions?
Someone just said.
Yeah, I'm not sure if the judge is disconnected. Yeah, because I think he's having some problem earlier. Yeah, I think that should be okay.
But the question is that what medium that I use, right? We're using the fiber as the medium for the transmission.
You can look at the chat there.
Where's the chat?
Yeah, okay. I think we got it. Yeah. Thanks.
Oh.
Okay, so any more questions?
Hi. I have a question. So just now you show us the video for your presentations, you show that you are using the FPGA for your optic generation code, right?
Okay,
So
for
but
the
in your
generator.
presentations, you didn't mention about how is the implementation of the FPGA. Yeah. I'm looking for these details of FPGA.
I didn't mention about that because we already showed it in the video that we use it as the code generator in the system design that I showed that where the code generator is entered to the optical switch. That's how the code enter how the FPGA is entered to the system, because the switch is used for the switching for each channel. It requires the time to change it, to switch.
Okay, so means that you are using the soft logic to do that.
What?
Soft logic to do
Yes.
this. Okay. Yeah, thanks.
Okay, maybe we have a last question from judges. If you have one more last question. Okay, so if there's more questions, thank you, Syed Muhammad Ammar and Muhammad Amirul and also Amirul Aiman for this presentation and also your effort in doing this project. Okay, so so I think all of the groups have presented their work, and I think this session will end, supposed to be at the end at 11 o'clock. Now is 1 minute after 11. So before we end this session, maybe the organizer or secretariat want to say something.
Tak.
You mean Penny? Miss Penny?
Yeah.
Okay, I'm Penny from Dreamcatcher. Thanks for all the teams that presented. Good job, and thanks to the chair also. For the judges, you may proceed to. There is another separate teams that you can go in for discussion on the scores. So if nothing from judges or any of the teams, then we will end for this section. That's all from my side.
So sorry, come again, Penny. What did the participant have to do before?
No. Participant don't have to do anything. Just the judges will they can proceed to another section for discussion. There's another link for them to discuss. Another section, the Teams, Microsoft Team, for them to actually do the discussion.
Okay, so that means can we end this session now?
Yes. Any more questions from the judges? Or you would like to? Any of the judges would like to comment on these judging sections for maybe each of the teams? Some comments on that?
Yeah, I think just want to thank all the very actively participating students. I can see a lot of effort, despite this hard time. So yeah, really appreciate the effort, and I do understand that sometimes there's some difficulties technically, right? But yeah, for contests like this, yeah, please reach out if you feel any problems using Intel hardware also, right? There's good enough mentors from Intel that can lend the support. But nonetheless, I think I do see a lot of very innovative ideas. Also, thanks a lot for all the supervisors for putting in efforts and making all this happen. So yeah, good job everyone. Just my 2 cents. Anyone want to talk about Swiheng?
Yeah, I think thanks to organizer Dreamcatcher as well as coordinating this. Thank you to students as well as our in-house Intel judges making this rather difficult but successful event. As a wrap up, thank you.
Okay, so any more? Okay, so thank you, Mr. Lu Tung Lun and also Mr. Wong Swee Heng. Okay, so there's nothing else from me. So I think we can end this session, and thank you everybody. Thank you to judges. Thank you to participants. You have a good job. Still still have a long journey to proceed for your career. Good luck everybody. And also thank you to Secretariat. Yeah. Okay, so you have done a good job. I think almost every year you have to conduct this competition, which for me is a good competition, good for encouragement to our students to explore new technology before they go for their job. Yeah. Okay, thank you everybody. Assalamualaikum warahmatullahi wabarakatuh, and good morning. Stay safe.
Thank you. Bye.
Thank you, Dr. Zaini. Thank you, all
Yeah.
the judges. Thank you, all the teams. Bye.
Sure, thank you. Bye.
Good luck.
Thank you, Dr. Zaini.